Okay, yeah, hello everyone. Today's lecture will be first in English. First of all, Friday lectures are back. Yay! So this is like a friendly gathering where we share our ideas, thoughts, maybe experiences.
And pizza.
And pizza, and coffee, and what else, drinks, yeah. So, hello everyone again. My name is Bogdan Serkins. I am a software developer at Dynina. My main work is connected with data and data processing, and also I'm very interested in architectures, software architectures, different kinds of them. And today I will try to tell you a story of how to collect data for ourselves and how to bring that data to use. So yeah, first there will be quite a lot of quotes here. First of them, data, I think, is one of the most powerful mechanisms for telling stories. I take a huge pile of data and try to get it to tell stories. Stephen Levitt. This guy basically tells us that the main aim of data is telling stories. And this is basically what we should aim at. If you're trying to create a report or, I don't know, calculate something or maybe view some, I don't know, feedback, the main idea of that data that you collect is to tell a story. And if you don't get a story, then you cannot actually bring the data to the real world. You cannot actually understand what's happening in the real world. So yeah, that's very important, and basically that's the motto of today's lecture. First of all, I'm a software developer, so there will be also quite a few things I will be telling about software and how it works and what are the key concepts of software. First of them is the architecture. Each program, Jira, Facebook, etc., Twitter has an architecture. This architecture can be defined, can be not defined, can be documented, not documented, but usually there is one. Actually, there are quite a few books on software architectures, and maybe I'll email the links later. Yeah, but today I will tell a story about a very simple one, the one that basically every application uses, every simple application that developers make. This is called layer architecture, where in an app, in a software project, there are multiple layers which interact one with the other. And this basically goes like this. Here are the three main, most popular layers, but there can be more. So first one is presentation layer. If you open a website, you see buttons and forms and maybe some tables. This is the presentation layer. That's what you look at when you use the app. And basically it's the app that you see. The second one is business layer. This is the layer of the app where there is business logic, where there is something that's happening and someone defined what's happening in there. Yeah, and the last one is database layer, where the data is stored. If you heard developers talk about the data and how we write into databases and how you read them, and the database is slow, there are servers and all that stuff, that's basically the technical layer where the data actually resides. So, and in terms of that collection and in terms of what we can bring from this to our world, from each of these layers, we can actually collect the data, because each of these layers does something. And the usual, the most common approach is, I see some people from marketing department here, so you'll be familiar with this. Presentation layer, actually, it's very easy to collect data from it, because if you heard of Google Analytics, that's basically it. You connect Google Analytics, you basically add a little script to the presentation layer, to the website, to the application, and you start collecting data. Additionally, you can collect some conversions. You can collect free-form events and all that stuff. And basically, you're done. About business layer and database layer, it's a little bit complicated. Usually, the most common, I'd say misconception, but yeah, basically, usually people do it. They consider business layer and database layer to have like the same common information that we can use. So when someone tells a person like, I would like to know what's in there, what's about that process that happens in the application, and usually people mean that they want to know the process, like what's happening from the business layer, but what they get is usually the data from the database layer. Like for example, if our application processes orders, and an orders happens, and we want to know like how many orders has happened, we actually want to know what happened on the business layer, like how many processes were there, but what we get is how many processes have we saved into our database. Like we get the residue. Actually, this is the database layer actually is very simple because you don't have to collect the data from it. Basically, you already own the data. So if you really want to know what's inside, you can ask a developer like, make me a table from the database, and you'll get one. You can, I don't know, add a plugin which shows you data from the database, and you're basically done. Yeah, but the thing is, in a service architecture, where we have a lot of projects, it's a little bit more complicated, and you can just, for example, if you want to compare two data from two databases, you want to take them and you want to see what's inside them, somehow merge data and see the report or something, you can do that. And basically that's the whole idea why special applications that process data were created, to be able to take multiple projects, take the data from maybe multiple layers from it and analyze it. And here will be a brief history on what it is and how it works. The term is a data warehouse. It's a place where we put all of our data to analyze. This is actually quite fun. The term was invented in 1990. So it's actually quite old, and the concept is very old. And the definition goes like this. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decisions-making process. So here's the breakdown. Subject-oriented. We want to know what happened, not how many things were there. Like for subject-oriented means you have a subject, for example, I don't know, a process. You're selling something, or you're collecting feedback, or people are like leaving you comments or something, and you want to know things about the subject. If you go into specifics, there are many of them, and it's actually very hard to define what you actually want from that all. Second one, integrated. That means like a lot of data comes in. Time variant. That means that almost every object is related to time. So when you analyze data, the first thing you need to decide is what's the timeline. Like what's the time, I don't know, dimension. For example, if I want to see the same orders, the first thing is what's the timeline that I want to use, like when the orders was created, when the order was processed, when the order was like done to something else. The last one is non-volatile. I had comments, but I don't. Then, sorry. I don't know what that is. Yeah, basically, Okay, that will be later. Yeah, and the decision making is also very important because we don't want to, like, for example, if we're talking about data collection for bookkeeping, that's like the wrong approach. If we're talking about data collection for, I don't know, if we're expecting from data that the data will give us some action plan, then it's also wrong. The one and only thing that data can give us is the perspective to make a decision. And we can count basically on only that. So yeah, and in history, it actually is a quite fun one, because in the very, very early days of databases, there were no databases, and actually people worked with files. So there were like a lot of servers where a lot of files reside, and for example, two businesses could communicate one with another just by putting one file from one server to another server. And that was basically it. Then databases come along. Databases basically allowed for people to work with the data simultaneously. So multiple people could actually work on the same data and read and write to the same place simultaneously without any problems. Because with master files, like if you have a file and both people simultaneously edit it, then you have a problem because like only one version of the file will be saved. Yeah, and with databases there was that problem that when, for example, you have multiple applications, then you have multiple databases, then it all goes, it's very difficult to collect the data and analyze the data and do something with the data. So the people decided that it would be easier to copy the data into special applications, which were called data warehouses or DWH. That's basically a special separate database which can give you the information. It's basically the same, only with the difference that the data is all collected. So yeah, and the next big thing is big data. It's actually quite frequently used term, which isn't very well defined. And this transition is actually the most interesting because, first of all, it happened relatively recently, and there was a very big shift in paradigm with how we collect and analyze the data. Because with data warehousing, we copied the existing data from the database layer. Basically, we took the result of business layer processes, which was saved at some point. We copied it, and actually we still do it. We started to analyze it. And that's basically was the whole approach. With big data, we do something differently. Apart from doing the first thing, we additionally generate the data. That's like the whole new thing. Because when you generate the data, like each part of your program, of your application, let it be Facebook, Jira, Twitter, or whatever, it generates the data. It doesn't provide you with the place like, look, there's a database, there's data, you can like check it. No, it generates the data over and over again at every thing the user does, or maybe not the user, the system. Yeah, and in terms of the amount of data. With the big data, like with this new approach, there is a lot more data to process, so the technology is also changed. But actually, in reality, data warehouses also are big, like few terabytes. Data warehouse is actually quite a normal thing. Yeah, and with the data itself, there was one very important thing that changed. In nowadays, in modern systems, for example, in Google Analytics, actually the approach is quite the same. The data tends to be immutable. The immutable means the following thing. Not subject or susceptible to change or variation in form or quality or nature. That basically means in the modern systems, which are oriented to be big data systems, you don't have the ability, or this ability is very, very much restricted to update your data. For example, if you have feedback, collection tool, application, whatever, and you collect comments and there are like tests and variations, and for example, a person in your app wants to change the feedback and like submit it one more time or like change one of the options, in modern systems, you will get 2 submissions and you will analyze 2 submissions. This is like the shift in data and the shift in paradigm. The problem is that the problem actually starts with the users, because technically programmers or implementers, it's very easy for them. Like there's the shift in paradigm and documentation just says, look dude, you can't edit the data. It's just not possible. And the developers looks like on this like, okay, fine, I can't. So the documentation says that, and that's basically it. For users, it's very complicated because you are used to the fact that you can define some terms, and like this happens. For example, there is an order, and the order in the process of the business changes statuses. Like it's opened, then it's in process, then it's shipment, then it's like done, completed, or whatever. And in the new world, in the immutable world, that doesn't happen. You just cannot have an object which changes state. You can have a collection of events that happens, and you can work with that because the event is actually mutable. So yeah, a little more on that. There's also actually another problem that is in there. With that, there is a common misconception that business layer and database layer are actually one and the same. There is a very big difference in that the business layer implements some processes. Like for example, if we have marketing newsletters and there are like no, that's bad. With the order and the transactions, it's actually very good. So yeah, for example, we have a system where there's order and there are transactions which like charge the money. And the business layer could say, okay, so we received an order and we can like make a charge. In the database layer, there even maybe may not be an order, only transactions. Because like what we see in the application and what happens actually in the database, in the technical layer, can be very different, completely different. And when, for example, a customer comes and says, I want to develop a feature, and it will work like that, then you actually have very little influence on what data there will be in the result. And because of that, you miss a lot of important stuff. Because when you come with a feature to developer into an app, or you want something to be done, the first thing you describe is the process. A user comes, or a customer, or whatever, and he will do something. He will click that, and he can click that, and he can select that, and there will be an error, and there won't be an error. You define very little on what will be in the data and what you actually want to analyze. So yeah, and basically what it means is common data warehousing can give you only the residue, the results of your business process. It cannot give you the process itself. And that is this main problem, and that is basically this main shift into the big data. So I have an example. This is actually quite good because we had it in practice. We actually haven't completed the implementation, but the whole concept is very simple, and it will help us, let's say so. Okay, marketing newsletter. We have a customer base, and we want to send them emails about our offers. It's like a very simple case. But we also would like to collect some statistics about it. And the process is actually very simple, and it's the following. We make a request into some system, like we want to send an email. Then the system processes the email and tries to deliver it. And it actually, if it delivers, then okay, the customer got our email. Then the customer can open our email or can spam it. And the last thing, usually in marketing newsletters, there is like banner or a link which the user clicks. So the customer can click the link and follow into our website, or I don't know, call us or whatever. So yeah, there are 4 simple steps, and nothing like magical. And in the result, we would like to have a report. Usually, it's also a simple report. We would like to have a marketing campaign, how many newsletters we requested to send, how many we delivered, how many we opened, and how many were clicked. As simple as that. But then it becomes a little bit different, because usually when you define the task like that, like I want to have a table or something, then most probably you will get this the data representation, which is similar to something like this. You have a campaign. Each email you send is defined with some identifier that you could track the process, those 4 steps. And when the system that processes the emails notifies us that this request was delivered, this 0 would change to 1. We would update the data. If the customer would open our email, then this 0 would change to 1. And this is this basic approach. In the data, we save almost the same thing that we were requested. So yeah, and when we would like to create this report, that's basically we count up the numbers, ones and zeros, and we can make a report, maybe even count conversion. Like in the end, you would get a report, and it's like a good thing. But there is only one problem. You will be very restricted in what you get. You get a table, a report, and it's basically it. And you get very little information. In the big data approach, you actually don't create an object and store additional information in there. You collect events about the process. And this is actually quite fun. The structure of what you collect changes drastically, but the most important thing is what you can do with these changes drastically. In a way that, for example, to do the approach where we don't change the data at all, we would collect not pieces of the information, but we would collect events from the process. And this would go like a campaign, which basically we need anyway, request ID, which we also need anyway, because we need to track somehow what happens. And also the event would have 2 fields, which are actually quite great. Created at when the event happened, and the type of event. Was it request? Was it delivery? Was the event notification that customer actually opened our email, or even the click event? So in this approach, we would have like multiple events which are immutable, that don't change, but also we would have a lot of information. First of all, we would be able to debug what actually happens in the process. For example, how many times we deliver an email. If we request one time, but the system could be buggy or maybe poorly implemented, and the system could deliver one email to the same customer multiple times, we could track that, because we would have multiple events of delivery for the same request. Also, how many times usually a client opens an email? How many times the client clicks an email? Maybe some clients open our emails multiple times in a bigger time interval. For example, every month, clients like to revisit their old emails, and they open them when they get interested. Also, for each of the events, you would get when this event happened. So these basically give us not only the report, like we could generate a report from it, we could just count the events also using the request ID, and it would be the same. Like technically it's possible, but you get the process. And this is like the basic idea of data collection. You don't aim for the result, you aim for collecting the process and working with the process. Yeah, some of the best theorizing comes after collecting data, because then you become aware of another reality. This is this shift in big data. This is basically it's another reality. Because when you get used to getting reports, you get the reports, you get the tables. It's all right, like you can make decisions on them, but you cannot investigate more in depth. You cannot see that the process is actually working. Because without the data, without the events that happen on the business layer, we can only like speculate. And even then, like in good systems where you have documentation and testing, and it all like passes, and the system is simplistic enough to comprehend, you can get assumptions of the database layer. You can get assumptions of what happens on the business layer. But if you don't have documentation, or you don't have testing, or the system fails often, or the database isn't stable, or the database has some bugs or other issues, you don't get anything from the business process except that you can go into the presentation layer, click some buttons, and hope that these buttons work. So yeah, another reality is basically the process saved in the data. The problem is that this approach, it actually generates a lot of more data than the previous one. Because we save not the necessary minimum for the application to work, but we save basically everything that happens in the system, and that's a lot more. So yeah, it's almost the end. Another very important part of this is the responsible person. This is actually a quote from a tech article quite a while ago, from the 12th year, which says basically the following, that in Facebook, there are developers and they change something. They make code, they break things, as they like to say. So, and the general rule at Facebook, at least at the time, was that if you are checking in code, that means adding code for those who are not a developer, like developing something and put it into production, you have to maintain your code. There were actually rumors that in Facebook there was code that was still at the time written by the CEO, and he actually maintained the code because he like needed to do it, because that was like the general rule. And at some point he stopped programming because like there was a rule, if you change it then it's yours. So yeah, the lesson from this one is actually quite simple. With the new approach, the big data, the events, that doesn't change, like it's the same. If you have a process that you're responsible for and you collect the data from that process, then this data is basically yours. If you don't analyze it, if you don't use it, if you don't manage it, then either you don't need the process, like this process can be removed from the application, or you don't have the data, it's just not that important. But yeah, if you create some report or make something for you to analyze and use it only one time, this means just that we did like a lot of work in vain, and you don't actually need it. It's just like a good thing to be responsible and to clean up after yourself, something like that. Yeah. So in the end, we have 3 layers. From the presentation layer, we can use Google Analytics or write our own app, or actually if it's Jira or I don't know, Facebook, Twitter, then there are some ready solutions to collect the data, and actually Google Analytics also collects events. In the business layer, the only thing we can do is collect like checkpoints, events from the process, what actually happens, and then we have the picture of what are up, what our process looks like. Every other source of information about the business layer or the processes that happen in the application is basically false. Because if you have documentation, it's sometimes incomplete or incorrect. If you have tests, then those tests just, let's say, they approve some assumptions, but usually tests don't cover all. And if you want for the truth and you don't have the data from the business process, then the truth can be found only in the code base. And if you're not a programmer, then it's like a dead end. And for the database layer, we have our good old data warehouse, or the direct access to the database. Actually, it's quite simple to get in there and view the data. There are a lot of tools which can be used to view and see what's actually happening inside. And at the end, the last quote, the ending quote, without big data analytics, companies are blind and deaf, wandering out onto the web like deer on a freeway. And it's actually very true. You can make assumptions, but without data, without actual data from the processes that happen, you can't make up much. Yeah, thanks. Questions, comments? All three languages, yeah.
Yeah, that was a great insight, and I was curious, like from your point of view, what do you see as the biggest issue from adopting this subject-oriented event tracking company-wide? In any adoption, in any shift, there are two things. First of all, adapting this approach is change, and in companies, especially in big ones, change is tough. It takes time. But besides the whole change process, there's a very extremely big shift in paradigm. Because in terms of data analytics, people are very used to the process that's introduced by developers of business systems. Like you come up to the developer, you describe a feature or a process, you tell them what to do. The developer will adjust it technically, maybe ask some questions, and then do it. And in terms of this old approach, it's basically the same. So it's just settling with the first thing that is
well, in terms of using this, in terms of users, yeah, it's very big change, and you have to get used to the fact that you are looking for a process. That should be the aim. If you're looking for a report, it actually doesn't matter what the approach is. You'll get the report. But what this report will give you in terms of insights, and also one very important question, what would you do if you need to adjust the report? Because in the first approach, where you change the data, you would first of all, in the very beginning, have much less data, and you have to define every step and every part of the report beforehand so that you can get the whole report. And in the second approach, when you collect events, at the very beginning, you can define the process, and you already have a lot of stuff. And adding things is just easier. But yeah, also it's the technical issue, because it's hard. For the first approach, you have the database, you have the tools, because the tools are basically maybe a little bit more advanced in terms of technology, but basically the approach is the same for developers. To collect events in a distributed system, for example, I know service architecture, it's actually quite hard, and to make the delivery rates good, to debug the data collection and all that stuff. It's also very hard to understand what's really happening. So yeah, there are shift in paradigm for the users, and the second part is actually the technical expertise to do this, and the capacity in terms of like hardware as well, and money. Okay, yeah, thanks.